Alright, welcome to the first Chapter 3 video here. This one's just going to cover Learning Target 1. Now I'm just going to go ahead and warn you that this chapter was one of the most challenging chapters for any 6th grader last year. I mean, this was really hard. We did it about the same time last year as we were doing it this year, and it is going to challenge you. So, again, I'll try to keep the videos short, but make sure you're going back and rewatching things if you don't understand. It's your responsibility to come in with a good understanding, and then we will then in class hopefully take what you have to come in knowing a little bit, because sorry, that was my phone. You have to come in knowing having a pretty decent understanding, so then we can really practice and even maximize our time together. So this is all about multiplying and dividing fractions and decimals. Okay, now the first 3 learning targets here are going to be the things that are going to be the 3 hardest, I think. I think after this it gets pretty easy in my opinion. But when you are modeling, and this is going to be very similar to what you did with bar modeling last year, and I know a lot of you said it was extremely difficult, and I know it is. So hopefully I can help you this year. We won't be doing bar modeling for all of these, but we're going to do a type of modeling that you'll see, and then hopefully it'll all make sense. So the first learning target here is I can interpret, which means model, and compute quotients of whole numbers divided by fractions. So you're basically going to be doing quotients. Okay, that means divided by. Whole numbers divided by fractions. Okay, that's what we're doing. So let's go ahead and flip to page 2. All right. So there's your learning target up top once again. So we can go ahead and look at it. Now I know, again, this didn't copy very well, so I need to figure out what's going on there. But we're just going to be able to take a whole number, and we're going to be able to divide it by a fraction. So like this question right here, we got this guy, and you can read it. It's probably really hard to see on your end if you're watching this on Schoology, but again, you got it right in front of you. Okay, it's dividing a whole number by a fraction. Lee cut 2 pies into pieces that were 1/4 each of a pie. How many pieces did he cut the 2 pies into? So, let me put this at a different perspective. Okay, if you had 2 pies, well, actually, let me just use their picture because they already got it, and we're cutting the pieces into 1/4, then you can see that we're going to have 1 piece, 2 piece, 3 piece, 4 piece, and then this would, I guess, be 5. Oops, sorry about that. 5, 6, 7, and 8. Okay, this is doing 2 divided by 1/4. You're cutting it into 1/4 sections. Okay, now hopefully maybe some of you are starting to make the connection. Okay, this problem is saying 2 divided by 1/4. Okay, and a lot of you might say, at least I'm hoping, this is how I wouldn't probably do it like this. But what I want you to do is I want you to make I want you to be able to show me that there's a relationship here between division and multiplication. So yes, this is saying the 2 pies, he's cutting them into pieces. Anytime you're cutting them into pieces, you're dividing. Okay, you're cutting them into pieces of 1/4. Now most of us would say, okay, if you're dividing each pie by 4 pieces, cutting each pie into 4 pieces like we did, well then I know that I can just do 2 times 8. I'm sorry, 2 times 4. Okay, and I'm going to be able to get 8 the same way. Okay, and what I'm trying to get you to see is that 2 divided by 1/4 is the exact same thing as 2 times 4. And the reason we'd be multiplying by 4 is because we're cutting each pie into 4 slices into 4 slices. It's the same thing we did. There's something, maybe you're seeing something here. Let me highlight it. There's something about that, and then there's something about the operation that's happening. We'll get to that. Let's keep working. Okay? All right. So let's go down here to this. Now, one more thing real quick here. I got to say this. I want you to please write this. This problem right here, 2 divided by 1/4. I want you guys to always get in the habit of always asking this question when you do these problems. How many 1/4 are in 2? And that's the ultimate question. And we always use that number right there, and it's always how many of that are in that. And it makes sense. Think about 4 divided by 2. aren't you saying how many groups of 2 are in 4? Yeah, there are 2 groups of 2. Okay, so I want you guys to start thinking about that every time, because when we start working on this in class, I guarantee I'm going to, every time, I'm going to say how many groups of 1/4 are in 2. Okay, now modeling. How we would model this question is we're going to go like this. We're going to take our first number right there, which is called our dividend. Okay, that's the number that's being divided up, and we are going to model it. Well, if that's 2, we're going to model it as two wholes. Okay, these pies up here are just to help you see the circle. This isn't the true modeling. I mean, that's a way you could do it, but I want you to really pay attention to my way here. Okay, so we have our dividend, that's 2. Here's 1 whole, here's 1 whole. That equals 2 wholes, right? Then what we're going to do is we're going to cut this thing into fourths, because that's what it's telling us. It's wanting to know how many 1/4. So the first thing we've got to do is we've got to cut it into fourths. Okay? Whoopsie. All right. Into fourths. Now we ask our question. How many 1/4 are in 2? Well, there is 1 there. I'll use different colors. There's 1 there. 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 How many total 1/4 do we have? We have 1 right there, 2, 3, 4, 5, 6, 7, and 8. We have 8 1/4 in 2. Okay? If that was a little bit confusing, let's do some more to really get this figured out. Now down here I wanted to make note of this. I want everybody to see this word reciprocals. Now I think you can't see it's highlighted on yours, so just go ahead and underline it. 2 numbers whose product is 1 are called reciprocals. So let me show you exactly what reciprocals are. The number 1, let's do the number, and I want you to write this, 2/3 and 3/2. Those are reciprocals. Okay, those are reciprocals. Okay? You can see that people want to say, well, it just flipped. Well, I don't like you using that word, okay? I want you to just think of this. You got to know this definition right here. We got to know this, okay? It's one of those important things, reciprocals. Yes, you are, technically, I guess, if you want to think of it, just flipping it. The numerator goes down and the denominator goes up. But what the real rule is, it's the only 2 numbers, reciprocals are the only 2 things you could multiply by each other and actually get 1. Now, let me show you how I get that. Remember, when we multiply fractions, we multiply straight across. We don't have to find common denominators. We don't have to do anything. We simply have to multiply straight across. So when I do that, 2 times 3 is 6. 3 times 2 is 6. We know that 6 out of 6 slices equals 1. Okay? So reciprocals are the only reciprocals of one another will always multiply to get to 1. Okay? So let's do another one. Let's take, 5/3 times. You should know the reciprocal of 5/3 is 3/5. Let's multiply straight across. It better equal 1. Let's see. Multiply straight across. 5 times 3 is 15. 3 times 5 is 15, which equals 1 whole. Okay? Let's do one more down here. What if I said this? What if I said 4 times, what's the reciprocal of 4? What if I asked that? Well, remember, every whole number has a 1 underneath of it. Okay? Because 4 divided by 1 is 4. Okay, now what's the reciprocal of that? 1/4. Let's do the math to make sure. Multiply straight across. That's 4/4, which equals 1. So, reciprocals. These are reciprocals. These are reciprocals of each other. These are reciprocals. Okay? That's going to be important, and maybe you're making a connection up here to what we did up here, if you'll remember, when we had 2 times 4 and 2 divided by 1/4. Keep that in mind. Let's go on. Okay. Okay, this is the same thing I just did here. And we'll talk about it here real quick. We have the number 1/2. We are going to do the reciprocal of 1/2, which that means the 2 has to go to the numerator, and then keep in mind that there's a 1 in every denominator. So that means, let me rewrite that. Let me white it out so you can see it. Okay? That means that 1/2, the reciprocal of 1/2 is actually 2/1 which equals 2 over 2, which then gives us 1. So the reciprocal of 1/2 is 2. 2/3, the reciprocal of 2/3 is easy. It's 3/2 because that's the only two things we can multiply by each other to get 1. That would be 2 times 3 is 6, 3 times 2 is 6, 6 over 6 equals 1. Okay? There's your reciprocal. Now some people say, whoa, Mr. Garrison, wait a minute. 1 times 1 equals 1. You can do those two numbers. Well, think about it. There's a 1 underneath of there. There's a 1 underneath of there. Think about it. Those are reciprocals of each other. Okay? 1 times 1 is 1. 1 times 1 is 1. 1 over 1 equals 1. Okay? Here is this. I just went over this. The algorithm. Okay, we're going to use that word more and more when we're talking about this. The divisor is always the number you're dividing by. The dividend is the number that's being divided. So here we have 33 divided by 11. This is your dividend. This is your divisor. Okay? That's going to be important. Trust me. So go ahead and pause real quick here, and I'd like you guys to just find the reciprocal of each one of these, A, B, and C. Okay? The reciprocal of 3/5 is going to be 5/3. The reason that is because if you multiply straight across, top times top, bottom times bottom, you're going to get 15 over 15, which equals 1. The reciprocal of 1/3, that's going to be 3 over 1. Or you could just write 3. Doesn't matter. It's the same number. Every whole number has a 1 underneath of it. And finally, C, we would put a 1 underneath of here. So what's the reciprocal? 1 over 11. This goes up, this goes down. And then again, if you multiplied them, multiply straight across, you would better get one whole. 11 over 11, which equals 1. Okay? All right. A bottle contains 2 quarts of cooking oil. A chef uses 1/12 quart of cooking oil each day. How many days will the bottle of cooking oil last? So what I've got here is I've made what we call a strip diagram. Okay, it's kind of similar to a bar model that you guys might have done. It's similar, I guess. We call this a strip diagram. And basically what I want you to see is we have 2 of these, which means this represents 1 quart. And then this whole strip down here represents 1 quart. Okay? So we know that if I use 1/12, okay, so I'm using 1/12 of cooking oil each day. So here's 1 day, here's a 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 day. So that means 1 quart of cooking oil is going to last 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 days. Okay? And again, if you added up these twelfths, 1/12 plus 1/12 plus 1/12 plus 1/12 all the way to here, you're going to get 12 twelfths. Okay, there are 12 little boxes in here, okay? So if that lasts 12 days, well then obviously this one down here is the exact same. That's also going to equal 12 days. So together, it's going to last 24 days. Okay? And realistically, what you're doing here is you're doing 2 divided by 1/12. Okay? Now what the algorithm is for division, guys, is the dividend will always remain the same. Okay, 2 is going to stay the same. This is the algorithm, so pay attention. Division is going to become multiplication. And then you're going to do the reciprocal of 1/12, which is 12 over 1, or just 12, which is 24, which is what we said. Okay? Basically what I'm showing you guys, what I'm trying to show you guys, is you could make the argument there's really no such thing as division in math. Okay? If I took a real easy number like 8 divided by 2, okay, we all know the answer is 4. But if there is no such thing as division, then you could say, well, everything's multiplication. Okay? Well, let's think about it. Dividend stays the same. Your division is just multiplying by the reciprocal. Okay? Everybody write that. Division is just multiplying by the divisor's reciprocal. Okay? Which makes perfect sense. Think about what I just said. Division is just multiplying by the divisor's reciprocal. So division is just multiplication. So division right here, as you can see, is becoming multiplication. And then which one's the divisor? It's always the one that's the groups or the amount in each group. Okay? The dividend's always the first number. And then now we got to do the reciprocal of 2, which is 1/2. 8 times 1/2, multiply straight across. That's 8 over 2, which is 4. Simplifies to 4. 8 halves is 4. Okay? Let's go on to the next page. Okay? All right. Here we got another example. This is more of a real life thing. I'm going to go through this pretty quick because I want to get on to you guys practicing some. Okay? Here, Rita, or Rena, I guess, cut 3 paper squares into a number of equal pieces. Each piece was 1/6 of a square. Into how many pieces did she cut the paper? So here's one paper, and one paper. So what she's doing is she is cutting it into 1/6. So each one of these is a 1/6. Again, there are 6 here. 6, 6 makes one whole. Okay? Well, if you go through there and think about it, how many pieces of paper am I going to have? Well, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So, 18 pieces of paper. Again, look at the way she's got it quoted here. This is how I taught you to learn it. How many 1/6 are in 3 holes? Remember when we wrote that on the first one? How many of the divisor go into or are in the whole or the dividend? Okay? So hopefully I'm really hoping that's making sense. So I want you guys to go ahead and practice. Now this is using the algorithm, and I expect you guys to know that word. Algorithm. Okay? That is, dividing is just multiplying by the reciprocal. So an example would be if I said 3 divided by 3. Okay? We all know the answer is 1, but this is actually turning it into a multiplication problem. Dividend stays the same. Divide becomes multiply. Use the reciprocal of the divisor. Multiply straight across. That's 3 over 3, which equals 1. Isn't that what we said 3 divided by 3 was? Okay, so you guys go ahead and do this. Don't mind the question marks. I hate that those are there. Just kind of right over top of them. Do these 6. Okay. All right, so here we go. The dividend is the first number. That one is going to remain the same. Divide becomes multiply. And this is going to become 5, because 5 over 1 is the reciprocal of 1/5. The answer is 15. Okay. 4 divided by 1/2 is going to become 4 times 2, which equals 8. Okay. Division becomes multiplication, as you can see, and then I do the reciprocal of the divisor. Okay. 6 divided by 1/5 is going to become 6 times the reciprocal of 1/5, which is 5, which equals 30. Okay. 7 divided by 1/4 is going to become 7. Dividend stays the same, times 4, which is 28. 5 divided by 1/3 is actually going to become 5 times 3, which equals 15. 8 divided by 1/8 becomes 8 times 8. And again, you could put 8 over 1, but it doesn't. You don't have to do that. I mean, we could do that all day long and say 64 over 1. But 64 over 1 equals 64. Okay? All right, let's go on to the next page. Okay, now we're going to get into some modeling stuff. Okay, now I've already done some, so let's just go through it here. It says take 2 paper strips. We're not going to do that, okay? But we're going to divide each of them. We're going to have our 2 strips. So it's already drawn for you there, but I want you guys to redraw it, please. So here's my 2 strips of paper. Okay? This is where it gets a little bit confusing. Okay? I'm going to do 2 divided by 2/3. 2 divided by 2/3. Okay, now remember I went ahead and I paused it and I put this little question up here. This is the question you've got to start asking yourself. You guys have to. You cannot just simply do the algorithm. I know that you guys know, or at least I hope you do, that if you were going to do this problem, division is just multiplication by the reciprocal. So you know that it should be 2 times the reciprocal of 2/3, which is 3/2. So if you go ahead and do that, that's going to be 6/2. The answer is 3. Now, unfortunately, guys, Common Core says you can't just find the answer anymore. It's not me talking, that's Common Core talking. We want you to model it and show me, how did you get 3? Well, let's do it. 2 is being broken to 2/3, so I want to know how many 2/3 divisors are in 2 wholes. So I go through here. I'm going to first of all cut it into thirds, like they did up there. Okay? Now let's start asking the question, how many 2/3? So how many groups of 2, in other words? Okay, we're looking for groups of 2. 1, 2. 1, 2. Get it, guys? I'm looking for how many groups of 2 are we seeing? How many groups of 2/3? Okay, it's already cut into thirds. Now we're just looking for groups of 2. Finally, groups of 2. 1, 2. Now let's ask ourselves, how many groups did we find? There's one group of 2. It's 1. There's another group of 2. That's 1. Here's another group of 2. There's 1. How many groups do we have? 1 plus 1 plus 1. There are 3 groups. Which, isn't that what we said the answer should be? Okay, let's do another. Now we're doing 3 divided by 3/4. So, to just edit the quick question up here, let me just grab it and bring it down here. Okay? And again, if you're confused right now, you're not. I told you guys this was going to be difficult. It's going to take time. Okay? Now let's just change the question. Notice I put how many 3/4 are in 3 wholes. That's all the question's asking. And I like to say how many groups of 3/4 are there in there. I guess I should add that, because that really helps me understand, and I think it will you too. Okay? So the first thing we got to do is we got to model our dividend. Okay? Our dividend is saying 3 wholes, so we got to model 3 wholes. Okay? Now we're going to take it and we're going to cut it into those fourths so we can look for them. Okay? Now when we ask the question, how many groups of 3 do you see? Okay, let's start counting them. 1, 2, 3. That's a group of 3/4. I hope that makes sense, guys. That is one group. That's one group. Okay, let's do a different color. Let's look for a group of 3. 1, 2, 3. That is one group. Okay, and it really does help to use colors here, so you guys are more than welcome. 1, 2, 3. That is one group. Okay, and then we'll use yellow. Hopefully you can see that. There's yellow. 1, 2, 3. That is one group. We can look here now. We can add up our groups. We had one group, 1, 2, 3, and whoop, just colored up the yellow. But regardless, you know that there's your 1. We have 4 groups of 3/4 in 3. We have 4 groups of 3/4 in 3. And if you use the algorithm, 3 divided by 3/4, remember, division is just simply multiplication by the divisor's reciprocal. So that's 3 times 4/3. Multiply straight across, 12/3. 12/3, 12 divided by 3 is 4. That's what we said the answer should be, right? 4. Covered it up, but there it is. It should be 4. Okay? All right. Let's see if we can get one more in here. Okay? I think that's, I got a bunch more on here, but I'm kind of getting short on time. Let's do this one real fast because I already got it made for you, so it's all here. Mrs. Johnson bought 6 pizzas. Okay? She cut them into many equal pieces for the students in her class. Each piece was 3/10 of a whole pizza. How many were there in the class if a child received only 1 piece of pizza? So this problem, what it's saying is, you have 6 pizzas. And what you're going to do is you're dividing it by 3/10. Okay? Now, using the algorithm, we could go ahead and figure out the answer if you really wanted to. 6 divided by 3/10. Well, that's going to be 6 times 10 over 3, which is going to be 60 over 3. 60 over 3 is 20. 60 divided by 3 is 20. Okay? And you can figure that out by doing long division. I'm not trying to skip that step. 3 goes into 6 twice. 2 times 3 is 6. 0, 0. Check everything. That is 0. Your answer is 20. Now let's go up and model it and see if we can find the answer using the modeling. Okay? So let's ask the question, guys. You've got to start asking the question every time. How many groups of 3/10 are there in 6? Now you can see we already have modeled the group of the holes, 6 holes. So each one of these represents a pizza. Okay? So we are looking for groups of 3. Let's do it. Ready? 1, 2, 3. That is a group right there. Okay? 1, 2, 3. That's a group. Let me use green. 1, 2, 3. By the way, I forgot to mention this, but these things are then cut into tenths because of the denominator of your divisor. These were cut into tenths. 1/10, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? All right, let's keep going. So we got a group of 3. 1, 2, 3. 1, 2, 3. Use a different color, mix it up a little bit. 1, 2, 3. There's a group. 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 Remember, I'm looking for groups of 3. Okay? 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. By the way, I try to always keep these a little smaller than what you're seeing here. 1, 2, 3. In other words, I don't usually do 6 holes. We'll do a lot of stuff with just 2 and 3 holes because it gets kind of time consuming. 1, 2, 3. Okay. 1, 2, 3. 1, 2, 3. 1, 2, 3. And finally, 1, 2, 3. Now let's go back and let's count our groups. Okay? Okay, there's a group of 3. Or I mean a group of 1. That's one group. 2, 3, 4, 5, 6, 7, all the way down to here, right? I'm counting the groups of 3, that's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So that means there are 20 groups of 3/10. 20 groups, which if you think back, I think I erased it, but if we could go back and remember the problem, 6 divided by 3/10 becomes 6 times 10 over 3. We get 60 over 3, which equals 20, which is what we found. Okay? So, to recap real quick, I know this video is a lot longer than usual. I apologize. I promise you. But again, this unit is difficult, and I don't want to hear anybody complain about it because, you know, this is something that I got to go slow through because this is something I saw it last year. Students are not very good at it, and that's okay. I'm here for you. Okay? But we've just got to make sure that we are really trying to really buy into what I'm trying to tell you, okay? So when we do these, 6 divided by 3/10, the first thing you do is model your holes, your dividend. Okay, so there's 6 holes here. Then we're going to cut it into tenths, okay? Whatever our divisor's denominator. Then we're looking for groups of 3. and that represents one group. Okay, so you made it, guys. If you're confused, we'll work on it in class the next day, and we'll get you where you need to be. That was it, and this is one of the harder ones. This is difficult, so we'll get you, I promise. So see you guys.